So next we have a few slides about TCP retransmission. Only 2 slides we have in TCP. That is very simple concept of how a TCP normally retransmits its data to the end user. Basically, by means of 2 important methods, we have the automatic repeat request and simplest ARQ protocol. As we know, automatic repeat request, the receiver sends acknowledgement when it receives the packet. Now sender waits for acknowledgement timeouts if it does not arrive within some period. So normally a time gap is being given. The sender transmits the data, receiver sends the acknowledgement. Now within that particular time, if the receiver not delivers the acknowledgement, the sender times out. Then you have the simplest ARQ protocol, which has the method of stop and wait. That is, sending a packet, it stops and waits until it gets another acknowledgement, which can be a positive or a negative acknowledgement from the server side. Then how long should the sender normally wait? Sender sets a timeout to wait for an acknowledgement. Normally it can be too short or it can be too long. Now too short means it can waste the retransmissions. Too long means there will be excessive delays when packets have been lost. So we cannot say that a timeout that is given to a sender can be a too long or a too short. TCP sets timeout as a function of the round trip time. As we know, round trip time is the time taken for a particular packet to be delivered from the client to the server, back from the server to the client. Expect acknowledgement to arrive after a round trip time. Normally, once a packet has been delivered, it reaches the opposite side, and from there you get, so within that particular stipulated time you have to get the acknowledgement, plus a fudge time to account for queuing. So this fudge factor, that is a small amount of factor, will be actually accounted for queuing. So in case of TCP retransmission, only 2 methods we have. It is the automatic repeat request and we have the simplest ARQ method.